All right, class, section 3.3, prove lines are parallel. You're proving the lines are parallel. I'm going to use the properties, or use properties to prove that those lines are parallel. It is kind of backwards from proving that angles are congruent. And that is the corresponding angles converse states, if corresponding angles are congruent, then lines are parallel. So if we know the angles are congruent, then we know the lines are parallel. So that is the converse. If you remember, a converse is switching the if and the then statement. So from the previous, it was if the lines are parallel, then the corresponding angles are congruent. This is if the corresponding angles are congruent, then the lines are parallel. So it is the converse of that. So corresponding angles converse, if those angles are congruent, then the lines are parallel. Then your alternate interior angles converse, similar, is if alternate interior angles are congruent, then lines are parallel. Then your alternate exterior angles converse. If alternate exterior angles are congruent, then the lines are parallel. And then the consecutive interior angles converse. If consecutive interior angles are supplementary, then lines are parallel. Then down at the bottom, the transitive property of parallel lines. If P is parallel to Q, and Q is parallel to R, then P is parallel to R. So we're talking about three different lines. If one is parallel to another, and that other is parallel to another, then the first and the last one are also parallel. That's a transitive property. If 1 and 2, and 2 and 3, then 1 and 3. Transitive property of parallel lines. So here in this example, we need to find the value of x that makes m parallel to n. If we look at these two angles, 2x plus 3 and 71, we notice that they're corresponding. They're corresponding angles. So we need a value of x that's going to make m and n parallel. For those to be parallel, these two angles need to be congruent. So we need a value for x that's going to make 2x plus 3 equals 71. So 2x plus 3 equals 71, and then we solve for x. And divide by 2 to get x by itself. And x will equal 34. And then if we plug 34 back in for 2x plus 3, 34 times 2 is 68. 68 plus 3 is 71. So those two angles are congruent now. So that proves that m and n would be parallel. Here we need to find the value of x that makes a and b parallel. So again, we see our angles are corresponding. They're corresponding angles with one another. So we need to set them up equal to each other and find that value of x that is going to make these two angles be congruent. So 5x minus 7 equals 98, and then solve for x. And x will equal 21. And then we plug 21 back in. 5 times 21 gives us 105. Minus 7 gets us back down to 98. So we would need x to equal 21 for those lines to be parallel. Oh, and then we've got a proof. Okay, so let's get back into proof mode. Make our 2 columns, our statements. And our reasons. We're told our given statement is angle 1 and angle 2 are congruent, and angle 3 and angle 4 are congruent. So we'll see 1 and 2 are congruent, so that is given. And we're also told 3 and 4 are congruent. That is also given. Well, if we know 1 and 2 are congruent to each other and 3 and 4 are congruent to each other, we can also see that 2 and 3 are vertical angles. So 2 and 3 are going to be congruent with one another. And that's the vertical angle. Vertical angles congruence. Okay, so we know that those are congruent. We're eventually trying to prove that A, B, and C, D are parallel. So we want to prove that these two are parallel. To do that, we need to show that 1 and 4 are congruent. So if angles 1 and angle 4, and we need angles 1 and 4 because they have an actual relationship with those 2 lines if they're going to be parallel. So 1 and 4, how can we get to angles 1 and angle 4 being congruent? Well, if we see angle 1 is congruent to angle 2, and angle 2 is also congruent to angle 3, and angle 3 is also congruent to angle 4, so therefore 1 and 4 are also congruent. So this is a 4-step transitive property. So normally we're dealing with 3 with transitive if 1 and 2 and 2 and 3, then 1 and 3. This is a if 1 and 2 and 2 and 3 and 3 and 4, then 1 and 4. So it still works, and it is transitive. Just going down the line of if 1 and 2 and 2 and 3 and 3 and 4, then 1 and 4. Okay, so now looking at angles 1 and 4 being congruent, what is their relationship? They are alternate interior angles. So we can see that the alternate interior angles of these 2 lines in that transversal are congruent. So therefore, we can say AB is parallel to CD because the alternate interior angles converse. You do need to state that it's the converse rather than the alternate interior angles theorem. So we were able to prove that the alternate interior angles were congruent. Therefore, we were able to prove that those line segments are parallel. So alternate, I have ATT. I'm going to erase that. There we go. Alternate interior angles converse. So we can do proofs with this too. All right, next, what theorem justifies each statement? So we're just naming for each of these statements. Angle 3 and angle 6. 3 and 6. What is their relationship? Well, they're alternate interior angles. And if we're saying that they're congruent, so it's the alternate interior angles. Oh, what theorem justifies each statement? The alternate interior angles converse. And then 4 and 6 are supplementary. And 6 are supplementary. That would be our consecutive interior angles converse. Consecutive interior angles converse. We see that those angles are supplementary, therefore those lines would be parallel. Then number 3, if the measure of angle 2 equals 115 degrees, measure of angle 2 is 115, we need to find the measure of angle 7. So the relationship between 2 and 7 is that they're alternate exterior angles. And for those lines to be parallel, those alternate exterior angles would be congruent. And we see the lines are parallel. So we can say that they're congruent. So the measure of angle 7 equals 115 degrees. Then number 4, we have a different image here. We need to find the value of x and y. So we can see our 2 parallel lines, and we can imagine them extending out a little further. 2 parallel lines in green. And then we have 2 different transversals. So our other 2 lines are both transversals. But we need to find x and we need to find y. Let's look at x. We have a 2x plus 10 and a 6x. If we look at this transversal, we see that 2x plus 10 would be alternate interior with our y plus 10. I'm not sure that helps us out a whole lot there. Not yet anyway. We need to find x or y before we can, or find x before we can do that. So let's look at the other information we're given, the 30 degrees there. And look at the other transversal. Now we can see that 6x would be consecutive interior with both of those angles together. So 30 plus 2x plus 10 is a consecutive interior angle with 6x. and those would be supplementary. So we could say 2x plus 10 plus 30 plus 6x equals 180. Because consecutive interior angles are supplementary, they're going to add up to 180. So we're adding all of those angles together to equal 180. Then simplify. We get 8x plus 40 equals 180. And then 140 divided by 8 gives us 17.5. So our x equals 17.5. And then we need to find y. So we already talked a little bit how we can find y. If we look at 2x plus 10 and our y plus 10 being alternate interior with this transversal, then we know 2x plus 10 is going to equal y plus 10. And then we can just plug in 17.5 for x. So 2 times 17.5 will give us 35 plus 10 equals y plus 10. 45 equals y plus 10. Subtract 10 to get y by itself. And y will equal 35. So x equals 17.5 and y equals 35. Then number 5, we need, the figure shows a plant trellis, and we need to find if the measure of angle 1 equals 82 degrees, find the measure of angle 2. So the measure of angle 1 is 82 degrees, and we want to find the measure of angle 2. We can see that these are parallel. This would be our transversal. So they're on the same side of the transversal, both on top of their respective parallel line. So they're in the same position on their line. So they are corresponding. So they're corresponding. We have the lines are parallel, and we know they're corresponding, so we know they're congruent. So the measure of angle 2 equals 82 degrees. All right, that is it for the notes. Make sure you do your homework.